So this is distributed operating system. One more thing is I just wanted to highlight. In real-time scenarios, a particular operating system can be a mixture of different kind of operating systems as well. But again, we are focusing upon different specializations, which is why batch is taken as separate. Maybe there's an operating system that takes the best things out of all of them and then does something, right? So again, distributed operating system. Distributed system use multiple central processors which to serve multiple real-time applications and multiple users. The data processing jobs are distributed amongst the processes accordingly. Okay, so let me just go ahead and check the slides because I think I want to give an example which is probably not there in the slide. Okay, so distributed. Okay, so I'll give you that example later. So distributed operating system is essentially, there's a distributed system which has its disk, its CPU, its memory. There's another which has a disk, CPU, memory. There's another which is this, and this, and which is handled by a communication system. Now, a lot of you may know about cryptocurrencies, may know about Bitcoin, Ethereum, and when I'm shooting this video, the price of Dogecoin has gone very high. And so basically all of these cryptocurrency, they work upon distributed systems. All over the world, there are computers that are doing computing. What kind of computing is happening? There are transactions which are happening. People are buying cryptocurrencies, people are selling cryptocurrencies. So they are updating the ledger, that who is buying, who's selling, and then transfer of all those digital certificates of transfer of the cryptocurrency, right? And then creation, which is basically mining. But if you look at it, what's happening here is there's no single system like maybe like in a bank that, okay, this is our CPU. Everything happens here, all the requests will come here. No, anybody can create a crypto mining system by using their CPU, right? Somebody is doing in China, somebody is doing in India, somebody is doing in Poland, somebody is doing in Germany, somebody is doing in US. Everybody is doing everywhere. So it's the central processing unit are spread out, are distributed, but all of them work together. Why? Because there's a communication between all of them. Any mining that is happening, so let's say if I mine something, it is sent to all of those systems which are doing the mining, and then they update their table of transactions. So that is the very classic example of distributed operating system, right? So that's in that case would be, again, to cryptocurrency mining, distributed operating system would be the best, right? So let's have a look upon the basic boring highlights of in terms of theory. That was just an example. Data processing jobs are distributed among processes accordingly. Processes communicate with one another through various communication lines such as high-speed buses or telephones lines. So in the case, high-speed buses and telephones lines is the older version. Now it's basically the internet, which are nothing but telephone lines only, or maybe satellite internet, right? They are referred to as loosely coupled system. Okay, the word here important is loosely coupled system. So they'll say dash is an example of loosely coupled system, or distributed is a dash, and then there would be very confusing word. So loosely coupled system. Primary, the most important task of distributed system is resource sharing, right? So resource sharing, again, written in green, anything written is green is important, apart from the headings, obviously. Make sure that is in your notes and you don't forget anything in the whole course. Do not forget anything that is written in green. I request you. Okay. Now, advantages. The advantages are the following. With the resource sharing facility, a user at one side may be able to use the resources available at another, obviously. Speed up the exchange of data with one another via electronic mail. If one site fails in a distributed system, the remaining sites can potentially continue operating. This is the most important example. So let's say nobody can say that Bitcoin is down. Actually, they can, but not really. Because let's say people can say your bank is down. Why? Because the whole system of the bank is centralized, and that central processing power is in under maintenance, not working. But since Bitcoin or any other distributed system, there are lakhs of distributed computing powers or computing systems which are separated. So let's say if one is not working, don't worry, one is not working, it will fix it and it will get updated. But all the other 9,99,999 are working, so the system will not go down. Better service to customer, obviously, if the system doesn't go down, so better service. Maybe in some cases it's faster as well, because let's say rather than me connecting to somebody who's in US, I will get connected to the system which is nearest to me, so the ping will be lesser. Reduction of the load on the host computer, reduction in the delays of data processing. So that's just like I said, data processing is not delayed because the closest system probably most likely would be allocated to me. Not necessarily true, but if the algorithm is written in such way that it is partial to this or partial to proximity, so in that case, right? So that's basically about the distributing system. In the next video, we'll take care about the time sharing system.